All right, welcome to chemistry. We're going to learn lots of stuff this semester. Why don't you introduce yourself? What's your name?
My name is Fred.
Hi, Fred. I'm Dr. Scott. So, why are you taking chemistry?
I want to be a doctor. I'm pre-med.
Oh, good, good, excellent. So, have you taken chemistry before?
No, I had like a beginning chemistry in high school or something. Maybe it was biology. I think I did.
Okay, that's good. That's good. So, are you afraid of the class at all?
Oh no, 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 no. I'm sure I'll do fine.
Good, that's excellent. Some people are really concerned, like chemistry is something difficult for them.
Actually, I'm a little concerned.
Okay, all right. Well, that's not a problem. We have to make sure that as we go through the slides and stuff, that if you have any questions, you make sure you ask uh, those questions. Is that okay?
Okay, I'll do my best.
And I'll be asking you questions too. So, all right. So here's an outline of the kind of stuff that we're going to go over today. Okay, and chemistry has been around for a long time, but even before chemistry, people were just studying matter, trying to learn things and try to figure stuff out, right? And now people call chemistry a central science because essentially what they're meaning when they say that is it describes so many different things. And as you improve your understanding of chemistry, you can improve your ability to understand and manipulate many other aspects of technology and science and the world around you. All right. I like to help students remember that chemistry is the where the rubber meets the road as far as how everything occurs. So when you want to understand everything that's occurring, and when we say everything, we mean everything, right? We can record constants with the telescopes way out to billions of years ago, and we see that they're the same as they are now as they were then. So these are the way things are throughout not just this solar system, but or our planet, but throughout the universe. Okay, um, and it's all around us. Everything that's occurring has to do with chemistry. Changes in chemicals, changes in everything. You hear a lot of talk about, oh, I don't like to drink that because I don't like to get chemicals in my body. Well, it's kind of an odd thing to say because everything is chemicals. And, I think what they mean when they say I don't want chemicals in me is they don't want harmful substances. But there needs to be kind of a better understanding, right? So everything around us has to do with chemistry. Chemistry is a science. Science utilizes the scientific method, right? The scientific method is a repeatable process in which we make observations, we form hypotheses based on those observations, and then we perform new experiments. And those experiments, the goal of those experiments is to try to identify whether our observations or our hypotheses were correct, right? And we refine our hypotheses and observations based on the experiments and the more observations that we make, right? After a while of this, you get equations. And when it's an equation, we call it a law, a physical law that describes something, how something works. And we also have this word theory. Theory, sometimes people use the word theory as if it's something that's not very well known, just an idea out there, and that's not a problem. But generally, in science, when we talk about theory, we're talking about something that it might not have an equation. It might have an equation, but it is something well tested and generally accepted. Okay, so a lot of this going forward in this first beginning here is probably going to be a review for many of you, but that's all right. Have you heard of this? Looking at this slide, Fred, does it make sense to you?
Yeah, I know about solids, liquids, and gases.
That's right. These are the states of matter, right? And we deal with water going from water vapor to from a gas to a liquid to a solid, right? Ice. So we have a little bit of understanding of this. And we know what it takes to go from, for example, from a solid to a liquid. What do we call that when we go from a solid to a liquid?
Oh, I don't know what you mean.
I mean, like, what is the process called?
You mean like melting?
That's right, yeah, melting. So when we melt something, that's solid to a liquid. What about when you go from a liquid to a gas?
That's evaporation.
That's right, evaporation. Very good. So we have solid to liquid, liquid to gas. Do you know what it calls when it goes from solid right to gas?
Oh, I remember I heard that. Oh, I can't remember.
That's sublimation. Sublimation. Good. And what happens? What do you call it when we go from a liquid to a solid?
Oh, I don't know what that one is.
That's just freezing, right?
Oh yeah, okay, freezing. I get that.
Yeah, so freezing. That's pretty straightforward, right? So, um, gas to a liquid. Do you know that one?
No.
That's condensation. Condensation, right? All right. So, plasma is another state of matter, and it is a state that's out there all over the place in terms of the universe. But we don't talk about it a whole lot here. But it's a gaseous state of matter that contains an appreciable amount of an electrically charged particles. Um, yeah, a plasma are incandescent lights, right? They're tubes with charged particles in between at a fixed pressure, right? Low pressures. Those are a form of plasma, right? Okay, so when we change the physical property, we call that a physical reaction. So when we melt, when we freeze, when we evaporate, all of these are physical reactions. And here I have kind of a chemical reaction, or an equation here. It's not a chemical reaction, so it's not necessarily the right thing to call it, but we see it going from a liquid to a solid. And the thing that you can tell is that the elements, hydrogen and oxygen, you probably have some familiarity, right? Uh, they're not changing the way they're connecting to each other. It's the same thing. The only thing that's changing is these states. And you have these little letters. This is an L in brackets, and this is an S in brackets, going from a liquid to a solid. What do we call that? Going from a liquid to a solid?
Oh, that's freezing.
That's right. So we're freezing. We're freezing the water. And really, we're just slowing down the motion of the water. We're lowering the temperature. All right, so here's one for you. When water boils on the stove, what are the bubbles that form on the bottom of the container as it boils? All right, so let's give the folks a second at home to think about this. Push pause, think about it, and then find an answer.
I already know the answer.
All right, all right. Well, what do you think it is?
They're oxygen bubbles.
Oxygen bubbles? How do you know that?
Well, because I can see them when I boil the water.
Well, see, that's what we might think, but really what's happening is that water is converting, as it gets heated, liquid water is converting to a gas. And so those bubbles are the gaseous water.
Oh, no, that's what I meant. Yeah, it's just water.
That's right, it is water. It's water, gaseous water. That's what those bubbles are, okay? So a lot of people get the idea that, oh, that's oxygen or hydrogen because those things are in water. But no, it's just liquid water being turned to a gas. All right. How about this one?
Dry ice is a solid carbon dioxide at room temperature. Pressure probably does not melt, but it sublimes. What does sublime mean again?
Sublime was the word we use when we say that it goes from solid to a gas, directly from solid to a gas.
Okay. So I think,
Hold on just a second. Let's give everybody a second to answer this by themselves at home, okay? So push pause if you need more time to think about it. All right, hopefully you push pause and you've had a chance to think about it. What do you think, Fred?
this is just carbon dioxide, right?
That's right. How did you know?
Because this is not a chemical reaction. It's just a physical reaction.
That's right. Sublimation is a physical process. Very good. All right. That's a good place to stop for this one.